so much. Let's get started. So my name's Scott Sandler, and I'm going to talk about our journey from PHP to Hack at Slack. This is me. I'm a backend engineer at Slack, and I've been there for about 4 years. And in that time, Slack has grown quite a bit. Today, we have about 10 million people using Slack every day, and the backend code base that I'm going to be talking to you about is responsible for processing every message, every file, every emoji, everything that happens in Slack goes through this code base. Some history on this code base. Slack launched in early 2014 with a PHP 5.5 backend, and we migrated to HHVM in early 2016. And the reason for this was really about performance. At that time, HHVM was much faster than PHP 5. And so it was really about just getting the speed out of there. HHVM is an alternative runtime for PHP that was developed at Facebook. So it's completely rewritten the PHP runtime from the ground up, but it's still about running PHP. And it wasn't for another year that we actually migrated to Hack. So Hack is a different language that also runs on HHVM. It's PHP, but with more data types, essentially, and a static type checker. So what does that mean, static type checker? It means that it's able to check your code and look for errors without actually running the code. So it can analyze all possible code paths in the code. So this is not about performance. This is about writing PHP safer, having less bugs, and having more confidence. And so you could say that we came to HHVM for performance, but we stayed because of Hack, because of the type safety. Today, obviously, PHP 7 got much faster, and PHP continues to get faster. So I'm not going to focus too much on the performance differences between HHVM and PHP in this talk. Really focus about the developer experience of writing Hack code. So since that migration in early 2017, we've been adding types to our code base and making more usage of Hack, and preparing for the newest version of HHVM, which no longer supports PHP code at all. It only runs Hack. So before I talk about our journey, let's talk a little bit about what Hack actually is and how it works. The fundamental experience of writing Hack code is interacting with a static type checker. It's called HHClient. It's a binary that you can invoke on the command line. But the way we mostly use it is through this thing called the language server protocol. And this will interact with text editors like VS Code and Vim. And it says server, but it doesn't run on another server. It still runs on your computer. So what this thing is it's watching the file system for changes to the code. It has a data model about the code. It understands the entire code base all at once. And so if you make a change to a function, and maybe you change its return type in a way that would break some of the call sites, you instantly get feedback on all the breakages. Even if it has 100 call sites across the entire code base, within milliseconds, before you even hit save, you get that feedback on what will be broken by that change. And that's coming from the language server protocol, where Hack sends this information to your editor and says, please display these errors in these files on these lines. Additionally, the text editor can ask Hack questions. It can say, I'm mousing over this variable right now. What is the type of this variable? Or where is this function defined? So on and so forth. So that's the language server protocol. So this is our first example of some Hack code, and you'll probably notice that it just looks like PHP. Hack still feels very much like PHP. Pretty much the only difference here is that first line is HH instead of PHP. And we have a very simple example of a type error here. We have a function that wants an integer, and we're passing it a string, and that's a type error. So this screenshot is from Visual Studio Code. We're showing the output of this error. And you can see in the bottom, the error has multiple parts to it. It says, invalid argument, this is an int, it's incompatible with a string. And it gives you the line numbers for where these errors are occurring. So it's a multi-part error. It tells you how it figured out that there was a problem. So line 3, this is an int, that's the type definition of the function we're calling. And line 8, this is a string, that's the type of the local variable that was inferred. In my experience, these breadcrumbs of information that you get with these errors mean that even on someone's first time writing Hack code, where they don't really understand the type system yet, they're still able to figure out and fix these issues right away. So this one is pretty trivial to fix, and we can just change it to an integer, and now Hack is happy. You've probably had this experience if you've used an editor like PHP Storm. How many of you are using a text editor where you get this kind of information? A lot of you. OK. So what I want to focus on is the features that Hack's type system has that PHP does not. And the first one that comes to mind for me is generics. So generics are a style of programming in which you write code in terms of types to be specified later. So you have functions and classes and data structures that can work with multiple different types, but you specify the type when you use it. And they're denoted by this angle bracket T, this type parameter. So here's an example of a stack data structure, class stack, that has this angle bracket T in it. This capital T is a type parameter. And you'll see that parameter repeated several times throughout the class's body. It's in the push function, it's the arguments of the push function, it's in the pop function. So the same data that you push onto the stack, you pop that same data off the stack, same data type. Now, the pop function returns a nullable t because if you have a stack that's empty and you try to pop, you will get nothing back. You get null. So this stack data structure could work with any type. You could have a stack of ints, a stack of strings, a stack of arrays, a stack of classes, and that's what makes this a generic data structure. But of course, you can do this in PHP without just putting that t there. So what does this actually provide for us? So the point of this is the static type checking. If we have a specific stack, that is a stack of ints in this example. We want a stack of integers. And we try to push the value 5 onto that stack, that's fine. But if we try to push a string into the stack, hack will tell us, hey, that's invalid. This argument is a string, it's supposed to be an int. So this is where the generics actually help us. If I define this data structure without the generics, it could contain any type, but I wouldn't be able to say what I want this specific stack to contain. Now, I don't have to actually explicitly specify those generics even. I can let them be inferred by the type system. So I can just say, S is a new stack, push the value 5 into it, and if I mouse over that x variable and ask hack what is the type of this variable, it's able to infer that the t type for this stack is int, which means that when we pop data off of it, we get a nullable int because pop is a nullable t. So the generics can be inferred. You don't have to explicitly specify them. This is different from something like Java, for example. In fact, this will even work with multiple types. We can have a stack, and then we can put an int and a string in it. And hack will figure this out. It still feels like PHP. It's still kind of a dynamically typed language at runtime. So you can have these things that contain both ints and strings, and hack says, OK, cool. It looks like this is a stack that has int or string in it. This is sometimes called a union type. Okay? So not having to explicitly declare these generics and letting them be inferred is somewhat useful in these classes, but it's really useful when you start using generics with arrays. So in PHP, we have two kinds of arrays. We have the associative array, or also called a hash table or map or dictionary. And we have the list-like or vector-like array. And in PHP, we only have one word that we can use to describe that, just array. We can't really say much more about what's in it, so we often use dot blocks above functions to describe the contents of an array. In hack, we can use generics to annotate the kind of array that we have. So we have, in the first example, an array string, comma string. That means string keys, string values. In the second example, we only have to specify the value type because we have a list-like array, so the keys are implicitly going to be integers increasing from 0. Okay? And hack is able to understand these types and differentiate between them. So here we have an example where we have a function that wants an associative array and a function that wants a list array, and we have this variable on line 7 that we declare that is a list-like array, and hack infers based on the shape of that variable, okay, this is a list-like array, so you can't pass it to a function that wants an associative array. So this is where inferring those generics is important because I don't have to declare this is an array of strings that is vector-like. It just infers that. And so it's able to tell me that this is a potential problem. So this helps because PHP arrays having these two behaviors can be very problematic in that there's some functions that will behave differently on integer-keyed arrays and string-keyed arrays, like array merge is one that comes up a lot. I've had a lot of bugs with that in the past. There's another problem we have with PHP arrays from the perspective of a type system, which is that when you try to get a key out of a PHP array, you could always get back null. Because when you try to access a key that's not there, PHP will log a notice, and then it will just give you null. So from the perspective of a type system, you should treat any value you get out of an array as potentially null. But that's very inconvenient, because you know most of the time that the data is there that you're looking for. And so if it made you do that, you would kind of not want to use it at all. And so what other languages do for this is they will throw an exception if you try to access a key that's not there. Hack didn't want to make that change to arrays because that would be a backwards incompatible behavior. So instead, they made new data structures. We have the dict and the vec. They're a lot like those associative array and list-like array, but they formalize the difference between those two types, and they're stricter about their data types. So if you try to access a key that doesn't exist, it throws an exception, which means now you know if you get a value out of that array, it is a string. It's not going to be null. So this helps make the type system more sound. There's another kind of array that we often see in PHP code, where we have different data types in the array. Here we have an array that has an integer type, a string, and even a complex type. And kind of the best we can do from a type perspective is to say the values are mixed. But mixed is not a very useful type annotation from the perspective of a static type system. What can you do with mixed? You can't really do anything with it. And if you have to pass it to something and use it like an integer or like a string, you'll have to assert on that type before you can use it, which is also very inconvenient. So it turns out there's a better way to deal with this. We have shapes in hack. And shapes are a new data structure that represent an array with a known structure. So you know what keys you expect to be there, you know what values, what the types should be. And some keys can be optional as well. At runtime, these things are still just PHP arrays, which is also very convenient, because if you get some data back from an API call or from a JSON decode, you can assert that it matches a shape structure, where it's even just an array. So what do shapes look like? This is our shape definitions. They're type definitions, where we have the name of a shape, and then we have a list of the keys that can be present. And there's kind of two very common examples of where we would use this. The first one, this is the options for an HTTP post function. So you're trying to do a post request. And if you're writing a helper library where you're doing post requests, one thing you'll realize is there are a million different ways you can do a post request. Sometimes you're going to want to pass form data. Sometimes you're going to want to pass a JSON payload. Sometimes you will want to be overriding the user agent. So you end up with a lot of optional arguments. And you don't want to make each one of those into separate function arguments, so you usually make something like an array where you can pass those arguments in. But the problem is that how do you specify which keys are valid in that array and what their data type should be? Well, you use a doc block. But this thing can actually be statically type checked with a shape. So when we're passing a key in there, if we typo the name of the key or we pass the wrong data type, it will complain and tell us you're not using the right options here. So that's the use case for this first one, where we have all these optional fields with a question mark in front of them. The second one is an example where we often have structured return types of a function. The HTTP functions, whether it's a post or a get, will always return headers, status code, and a body. They'll always return that. And this allows us to describe what that return type is in terms of which keys will be present and what the data types of those keys will be. So then when we use that function, when we use that function's results in some code, the type checker is aware of the values that are in there. Let's zoom in to how we actually use these optional keys with shapes. So the way that we use them is we have to first check that they exist because they're optional. We use a built-in function, check that a shape key exists, and then we can use it to, for example, build a query string. And that's all well and good. There's something subtle that's going on here, though, which is that the type system has learned something from this check that I did. So this is, again, mousing over the value in Visual Studio Code and saying, what is the type of this thing? So you mouse over options before the if statement, and that form data key is optional, because it's optional in the shape. It might not be there. But inside the scope of that if statement, it is no longer optional, because we have checked that it exists. This is called type refinement. So what the type system did is it learned something about the variable from the check that I did. And now it has a more specific type, and that's why I'm able to use that field. And as soon as we exit the scope of that if statement on the code below there, it's once again an optional field. Might not be there. So that's type refinement, and Hack will do this for any kinds of checks you do. If you check for null, if you throw exceptions, check that something is a string, so on and so forth. It will track the types of variables as they flow through flow control. They could be different types, and it will keep track of all that. Let's talk a little bit about the standard library of PHP. So PHP standard library gets some flack for a couple of issues, one being the inconsistent argument order. I always have to look up array map and array filter and which one takes the array first. If you don't have static analysis set up, it's really easy to get this wrong. And another common issue is that the built-in functions often will return either the data type you want or false, and you have to check for both. And from a type system perspective, there's not a good data type that represents those two types. There's another problem that I often see with PHP code, which is we have things like this where we're calling a bunch of functions. We're sort of composing function calls together. And it's very hard to read for me. So if you want to read this code, you kind of have to start in the middle. You have to say, OK, we have a file name. We're exploding it on slashes. We're going to the end of that, getting the last result. We're exploding that on dots. And then we're keying into that and getting the first element of it. And your eye has to jump all the way over to the other side to see that we're actually keying into it. It's really easy to misread this or not understand what the type of the data is that's going to come out of this. And it's not super easy to refactor this in a way that feels ergonomic and readable. So with Hack standard library, it has a new standard library. You can still use the PHP standard library, but it has a new standard library that solves some of these problems. So the primary argument of a function is always the first one. Things that would have returned false now return null. And everything is namespace, so it's easier to find the functions. And we have this pipeline operator. That's the thing that I care most about here that lets us chain function calls. So what does that look like? This is that same example rewritten with the Hack standard library. So the magic here, this is like a bash pipeline, but the magic here is this double $, which refers to the result of the previous element of the pipeline. So in our pipeline here, we start with this file name, and then we pipe it to the string split function, which is like explode. We pipe that to the last function, so we get the last element of that. Then we pipe that to stir split again to get the dots, and then we get the first element of that. So it's the same code. This takes some getting used to, the syntax. I honestly avoided it for about the first 6 months because I just didn't quite understand it. But the advantage to it is that you read the code in the order that it runs. So you're able to make sense of the way that the computer will actually process the code that you have written. That's very helpful. Another feature I want to highlight with Hack's HSL, the Hack Standard Library, is this regular expressions that are typed. So we have these strings, these RE prefix strings, sort of like Python, where you have a regular expression string. It's a special kind of string. And Hack will statically validate the syntax of that regular expression, so it knows that it's a valid regular expression. It will fail the type checker otherwise. And it will also inspect the contents of the regular expression, and it will understand which capture groups exist, both named and numbered capture groups in there. And then the type system is aware of what the type of that return will be. So here it says this regex match. It has a subgroup called word, and that means that the return of this will be a vector of shapes that has an element called word. And so then I can use that element. If I try to access an element that doesn't exist in that capture groups, it will complain. For me, this was life-changing in terms of writing regex, because before I would always have to kind of var dump the output of regex match and see what it actually looks like before I used it, because it was always different. This makes that much better. One last feature of Hack I want to highlight is XHP. This is a way to build type-safe HTML in Hack. So if you've ever seen React's JSX, it's very similar. This was before JSX at Facebook and inspired JSX. This was actually originally created as a PHP extension, even before Hack existed. But what this gives us is a way to build HTML with type safety. So it knows for all the built-in HTML5 elements if they exist and what the names are of all the attributes they accept and what the types are of those attributes. So we get validation on that. We get automatic XSS escaping, and we also get all those features for custom classes that we write. So we're able to compose built-in HTML elements with our own classes. And this was powerful enough that we have all of Slack's server-side rendered HTML using this now. OK, there's a lot more with Hack that I don't have time to talk about. In particular, async await is how we do multiple things in parallel. Kind of requires a lengthy explanation. But I want to get on to Slack's journey with Hack. So this was kind of our pathway to migrating to Hack. And I'm going to go through this timeline one element at a time and talk about what was interesting along the way. So the first part of the migration was to just find and replace PHP with HH. And it was actually just that easy, just one sed one-liner. And this HH without the strict after it is Hack's more permissive mode, where it doesn't require everything as typed. It'll let you do a lot of the things that you would do in PHP. So it's meant for this migration. And that was easy, right? But of course, Hack had a lot to say about the code as soon as we did this. There were many errors that it pointed out. And so we couldn't just kind of run with this and say git commit, and we'll fix it later. What we did is we started fixing the bugs that it told us about. And there's kind of two main categories. There was actual hundreds of bugs, incredible number of bugs that it discovered. And there are also cases where just the type information that's available to the type checker makes it think there might be a problem that in practice will not be a problem. And so we kind of divided these up into two categories and fixed the ones by hand that we could. And there's also automated tooling that enables the migration. So for some of the things that are different between Hack and PHP, the tooling will just transform the code to conform to that. For example, adding a leading slash to any code that's in namespace that calls root namespace functions. It'll just handle that for you. And the worst case scenario is we can just say to Hack, oh, OK, I want to suppress this error. So you just put a comment above the line that's throwing an error. You say, I want to fix this later. And Hack will stop complaining about that. So we use these three strategies to get rid of all the Hack errors, and we would commit the code incrementally. So basically, Hackify some files, and then once they're passing the type checker, commit them, and then keep doing that as we would incrementally do the code base. And we did this with a CI test setup and continuous integration test that was running the type checker, so that we would not commit any code that doesn't pass the type checker. So in this way, we were able to slowly and gradually migrate all of our code to be conformant and be Hack. There's one other piece that we had to deal with before we really started using Hack syntax more, which was our linter. We were using PHP code sniffer. How many of you have ever written a PHP code sniffer lint rule? Not too many. The way that they work is you have to operate on this stream of tokens. And essentially, every lint rule that you write is a mini PHP parser. We had a lot of custom lint rules, both for style things and also for kind of trying to prevent bugs. It was our first foray into static analysis. And with Hack, there's a new tool that uses an abstract syntax tree. PHP also has an abstract syntax tree now. It's basically a more structured way of looking at your code. So rather than looking at one token at a time, you can look at expressions as a holistic thing and understand which elements exist in those expressions. And it allows you to write more rigorous linters with less code. And we also are able to use it for those migrations. We're migrating code from one format to another. So once we did this, we were at the point where we're like, OK, we're ready to use Hack again a lot more, right? There's one more thing we had to do, actually. Hack does not type check code that is at the top level, anything that's not inside of a function, which was surprising to me and was surprising, I think, to everyone who first learned this. So why is that? The reason is that in this context, all variables are global, so they could change at any time, at any point in the program. And we can't really reason about what their type will be. Additionally, code that's at the top level like this could run at any time as a consequence of auto-loading or the include statement. And so that means Hack also has no way of reasoning about what the call stack will be and what the state of the program will be when this code runs. So because of those two things, it just doesn't fit well into the data model. They don't allow this. And in the partial mode of Hack, they're just not type checked at all. In its strict mode, this is not allowed. It's a parsing error. So we had to migrate all of our code into putting the code into functions. This was especially relevant for controllers and CLI scripts and things like that. And Hack does provide this little entry point attribute that says, if this is the entry point of the request, run this main function when we start. So it won't run that if it's the side effect of an auto load, but it will run it when it's the entry point of the request. And that's what we want. So this was our second round of kind of finding a bunch of errors that we had missed in the first round of hackifying things. And finally, we're at the point where we're like, OK, we're using Hack everywhere. What do we do next? We need to actually get types into our code. We were using PHP 5.5 before this, which meant we basically had no type annotations. We had no types for arguments. We had no types for returns. And we thought about what was the best way to do this. And the place we wanted to go was to start with the database, because the types come from the database, and they bubble up into the code from there. So if we can get types from the database, that gives us a foundation to build on and add types everywhere else. We had a problem we wanted to solve when we were doing this, though, is that we were using MySQLi, the PHP MySQLi extension, which returns all data as strings. So even if you have an integer in the database, you get a string back in PHP. And that behavior was maintained in Hack with MySQLi. And so we wanted to migrate to their custom MySQL client, which is asynchronous, so we can run multiple queries in parallel, and also returns typed data. So this is an example. Before, we have this table that has an ID that's an integer. If we select from that table with MySQLi, we still just get back strings. This caused a lot of bugs for us. I remember one in particular where someone had a constant that represented the Slackbot's user ID, and it was an integer. And they compared it with some data that came out of the database. The database is an integer. But in PHP, it was a string. So they used a triple equal sign. The comparison fails. And for a little while, while that bug existed, no one could talk to Slackbot. And this kind of stuff happened to us all the time because it just continually surprises everyone who's worked in other programming languages when they get a string back for something that's an int in the database. So we migrated to the async MySQL client to get typed data. This code example uses async await, but the important thing here is this map_rows typed function where the data we're getting back is typed. And then we're able to assert that that typed row matches a shape that we have defined. So how do we make these shapes? We wrote some code that parses the SQL create table statement, and we generated a shape for every database table that we had. And basically, every MySQL column is either going to be an int or a string in Hack anyway. So it was pretty easy to sort of bind these things to there. And now we have these data types for all of our database tables, so we have a place to start bringing types in and getting them up throughout the rest of the application. There's one more way that we can get kind of the foundational types, which is there's this thing in HH Client called infer return type. You can ask it, what do you think the return type of this function is? And it will try to guess. And if it's returning a hard-coded value, the result of a comparison, something that comes out of a built-in function that has a return type, then you will often be able to get the return type for free. And Hack will just tell you this function returns a string. If it doesn't know, it'll just say dash. So what we did is we made a script that just ran this for every function in the code base and said, what's the return type? We added all the easy ones. And so now, once again, we have a big swath of types. We focused on return types first, not argument types. And this is one of the things I learned doing this, because return types give you a type that's useful in all of the call sites, whereas argument types are kind of only helping you within the function's body. So you get more bang for your typing buck if you're thinking about adding types by focusing on return types first and argument types second. Both are still valuable. We really wanted to deal with these untyped functions because we learned very early on that there's sort of this fundamental problem when you start adding types is that any data that comes from an untyped function has an untyped value, an unresolved type, or the any type, which means you can pass it anywhere. You can do anything with it. Hack does this because it has to do this to enable the migration. Otherwise, you would have to type all of your code at once, and you couldn't really migrate. But it leads to this kind of uncanny valley, where you have this type annotation, but you can't quite trust it. Because what would happen if we try to pass this string that's untyped into an integer function is we would just get an error logged at runtime. This error is called irrecoverable error. It's not a fatal, so the request keeps going. And we have now discovered a problem. So the way that we dealt with this is by taking the error logs from those errors and aggregating them, and we built a Slack bot that would just post them in channel so that we could see what errors were happening. and then people would triage them and fix them. And this allowed us to go through a cycle in this stage of just adding types, finding errors, and fixing them, and we just continued iterating on that. Luckily, with these recoverable errors, there's no user impact here. So as we're adding type annotations, we're not breaking things for users. We're just discovering places where, wow, we were actually passing an array to a function that wants a string, and I guess it was still working, but clearly not what we intended. So we found as we were going through this that every little bit of effort that we invested into adding types to our code provided dividends in terms of benefits. We found bugs while doing it. We saw the bugs we were preventing as we started adding more types. And we started thinking about how do we quantify this? How do we talk about types? Well, the way we talk about tests is we talk about test coverage, how much of my code is covered by tests. And we can do the same thing with types. So Hack has this tool. You can say hhclient-color, and it will colorize the output of a file. It will tell you which regions are untyped. So anything that's in red is something it does not know the type of. But we can also get numbers for this. We can say hhclient-coverage, and it will tell us how many spots in that file are untyped, both functions we call, local variables, everything like that. And so we paid attention to this number at the bottom right, which is the total coverage. And in this case, we're passing a file, but you can also just ask it for the whole code base, what is the coverage? So we took this number and we recorded it after every pull request that got merged into our master branch, and we also recorded who was the author, and we made a leaderboard. And we would post this into Slack every week, and this was hugely beneficial to us because everyone was just excited to be both competing with each other but also working together to make the thing better. And so that was our coverage competition. And that allowed us to get to the point where we could actually have enough types to start adding that strict annotation. This is where everything in a file has to be typed. This is when I felt like we really found, OK, this was actually worth it. This is really beneficial. And at this point, we're at about 75% of our files are strict. The last thing we had to do on our journey to migrating to Hack was to eliminate our vendor PHP code. And this was the hardest part for me, because we had a lot of these PHP dependencies we were installing via Composer. For every one of them, we had to replace it with something that we either wrote ourselves or Hackify it or pull it out into a web service and run it as PHP. We completed that and got to the point where we were actually able to upgrade to the latest version of HHVM that does not allow PHP at all. So lessons learned from this. We found and fixed thousands of bugs. I think it's incredible. When you first set up static analysis, it's like lifting up a log where there's ants under the logs. Like, how could there be that many ants in this log, and yet we didn't know? Because we had found and fixed all the bugs people reported, but all of these other bugs just existed and were kind of waiting to be found, and Hack was able to find them. There are entire classes of problems that we no longer have as a result of this. But in terms of quantitative results, we didn't sort of take half of our programmers and have them write PHP and the other half write Hack and see who was faster or who had fewer bugs. So we actually measured this in terms of developer sentiment. How do you feel about your code? And we found that with survey results, everyone felt more confident in the changes that they were making, and they felt more productive. There was basically nobody who felt like this wasn't an improvement. And I felt like we had this sort of test pyramid, this traditional test pyramid, where we have the most unit tests and then fewer of the tests that are slower to run. And types kind of filled out the bottom of that pyramid for us, where every type is like a cheap unit test that just is resilient. It's always going to be there for you. It's always providing value. So types are the cheapest unit tests, but only when you have a lot of them. When you just have a few, they're not doing much yet. And they're also the cheapest documentation, because doc blocks are often out of date unless you have some tooling keeping them up to date, whereas types have to be right. I also learned that typing is best done as part of feature work. When you're actually working on the code for other reasons, that's where you go in and add types, because you already have eyes on it, you already have QA, you're testing it, you know what's going on there. If you try to just go type some stuff without doing that work, it's hard to know where to stop. And you just kind of keep going, and you have this big spider web of a PR that's touching every file. It's better to do typing in the code you're actually working on anyway. So you might be wondering, should you switch to Hack? If you found this compelling, the community would love to have you. I don't expect that everyone in the room will do that. Obviously, losing your Composer dependencies is a huge ask, and you would also be taking a bet on a very small community of developers. Facebook is the only people that support this. We contribute a bit to it. There's only a couple of other companies using Hack. So I don't expect that the entire community is just going to switch over. What I would like to encourage you to do is to bring Hack's best features back to PHP. And this is already happening. There's many features that Hack has implemented first, which have been now either coming to PHP, like the arrow functions. We had lambdas in Hack. Generics has an RFC open. I would encourage you to vote on that RFC or try to get people to vote on that RFC. It hasn't been voted on yet. I think it's one of the most important missing features in PHP. There's at least 3 big community packages for static analysis. I would strongly recommend you to use one or more of these if you don't already. And you can have all of this stuff. There's really nothing that Hack's doing that PHP can't also do. If you want to make your code base in a good place for static analysis, there are some features of PHP I would recommend avoiding. These things are things that are banned in Hack. You should probably ban them in your linter if you have one, because they inhibit type safety. Eval, for example, global variables, they could change at any time. You don't really know if they exist or what their types are. References might surprise you to see that on this slide. The reason for that is that you can have a reference, you can store it in an array, you can store it somewhere, and then change its type, and all of a sudden we don't know what type it is anymore. So Hack banned references because they couldn't reason about what the type would be in a sound way, and they replaced it with a feature called inout that would just allow you to pass data into a function and get it back out, but not store and mutate that variable in every context you want to. So write your code in a way that makes static analysis possible, and you'll have a better time using these static analysis tools. And contribute to those tools, file issues against them, improve them, and you'll have all the same stuff. All right, that's all I have. Thanks so much, everyone.